All right, this is about acid and bases. You mentioned that too.
Yeah.
Okay.
Is it on page 18?
Yes, page 18 of 20. Let's look at some of these rules you will need. For instance, preparation of salt. To prepare salt, there are many ways you can prepare salt. One of the ways is to reaction between metal and acid
Yeah. Salt and
gives you
hydrogen.
salt plus hydrogen.
Yeah.
Can you write an example? Give me an example.
Metal acid.
Metal like what can I use to be? Okay, let me use blue for the
Like aluminium plus
aluminium
chlorine.
plus HCl will give what?
Salt and hydrogen.
Yeah. So what will you give? What will the salt?
What do you mean?
Yeah. You said aluminium in place of metal, and you said
Yeah.
HCl in place of acid. So what will you say for the salt now? Let's be
Wait,
specific.
what? Are you mentioning like different kind of salts?
Yes, just like you said metal. When you said metal, you mentioned aluminium in particular. When we said acid, I mentioned HCl. So when we get to the salt, we need to talk about the salt produced by aluminium and HCl.
I don't know that on the top of my head.
By the way, oh, that's cool. By the way, aluminium will take the chlorine by this
Yeah.
what we call displacement reaction. Aluminium collects the chlorine from HCl and then it becomes AlCl. But then what will be the formula of aluminium chloride?
Aluminium chloride. AlCl.
Are you sure? Aluminium is 3 plus, chlorine is 1
Oh,
minus.
AlCl3.
AlCl3. That's a salt. Then of course plus hydrogen. So plus hydrogen, just a moment. Plus hydrogen H2. Later you can balance the equation. Okay.
Yeah.
All right. I could write other examples. Like, what example can I write? Okay, let me give you
For
this. Let me give you this one.
yeah.
Let me give you um, lithium plus H2SO4. H2SO4 is
Yeah.
sulfuric acid. Gives what? The lithium will collect the sulfate. The lithium collects what?
Sulfate.
It becomes what?
Li4
You,
SO.
do you remember what SO4, the valency of SO4?
It's
Two minus.
yeah.
Our previous slide, the valency of SO4 we discovered is 2
Yeah,
minus.
2 minus.
So LiSO4, how will it be written? Lithium sulfate, how will it be written?
Li.
By the way, valency of
Uh,
aluminium is 1 plus. Can I say that again?
yeah.
Valency of
Of
aluminium,
wait, of aluminium.
lithium, valency of lithium,
Yeah.
sorry, is 1 plus.
Okay, so it'd be Li
Mm-hmm.
for Li2,
Good.
and then would it just be SO4 because there's only one lithium?
Good.
So we need.
So
Oh, so you
Li2,
don't need to
just
bracket.
SO4, you don't need to bracket.
Okay.
Yeah, remember SO4 I said is 2 minus. Li is 1 plus. So there will swap valencies. The 2 comes to Li. The 1
Yeah.
goes to SO4. So it becomes Li2 SO4. So
Okay.
remember plus hydrogen, isn't it?
Yeah.
Because metal plus acid always gives salt plus what? What's the general rule?
First acid it gives you salt and hydrogen.
Salt plus hydrogen.
So you know the salt part. Would that just be like, uh, basically it would be the elements together, but you just leave out hydrogen, don't you? So you know how Al plus HCl, you leave out the hydrogen, but um,
Yes, but then
I can't explain it properly.
exactly, that's what you get. In fact, salts are usually formed by a metal and a non-metallic ion.
Yeah.
Aluminium is a metallic ion, chlorine is a non-metallic ion, so they combine, you know. Li is a metallic ion, SO4 is a non-metallic ion. So when they
Yeah.
combine, it's the salt. You know, when we say salt in chemistry, it doesn't necessarily mean the common salt we use, even though common salt is also an example of a salt. I mean NaCl. What's the formula for the common salt we use at home? Table salt.
The equation for it.
The yeah, when we say formula, we mean equation. The chemical formula.
I don't know. It's just salt.
Okay, is sodium chloride.
Oh, sodium. Oh.
So what's the formula for sodium chloride?
Sodium chloride
Yep.
is sodium plus chlorine.
Sodium is 1 plus, chlorine is 1 minus.
So it'd just be NaCl.
Good.
Yeah.
Because sodium is 1 plus, chlorine is 1 minus. So when they combine, it just becomes 1 from chlorine comes to sodium, 1 from sodium goes to chlorine. It becomes just NaCl. That's what most people know as salt. In fact, that's the common table salt we use at home. It's actually sodium chloride. But there are other kinds of salts. It's not the only salt, okay?
Yeah.
For instance, lithium sulfate is a salt. Like you said, when you take out the hydrogen. But there are other things involved.
Yeah.
Aluminum chloride is a salt. Okay, that's the first rule. The second rule is what?
Metal oxides plus acid is salt and water.
Salt plus water.
So something plus H2O.
Yep. Can I give an example? Give me an example of a metal oxide.
Metal oxide. Aluminium oxide.
Oh, good. Magnesium oxide. I hope you know that magnesium oxide will be MgO because magnesium is 2 plus.
And oxygen 2 minus, and then you simplify it, it's MgO.
Okay, so MgO plus what can we use now? Let me use sulfuric acid. Sulfuric acid is H2SO4.
Sorry, yeah. So then that would be it would be H2O. That would be Mg.
You know the Mg.
Would it still stay as MgO?
No, remember to get the salt, you want to form the salt. The Mg combines with SO4.
SO4, yeah. So it'd be Mg2. Oh, that would just be MgSO4 because like
The 2 we cancel out 2.
yeah.
You would have written Mg2 SO4 2, in a bracket. But there wouldn't be any need because the 2 we cancel out 2, isn't it?
Yeah.
All right. And why did you write that? Because Mg is 2 plus. SO4 is 2 plus. 2 minus. Mg is 2 plus, SO4 is 2 minus. So 2 from SO4 goes to Mg. 2 from Mg goes to SO4. But you don't need to have because when you simplify it will just be MgSO4, isn't it?
Yeah.
So this is the way it should be, MgSO4. Just MgSO4. Alright, that's the salt, MgSO4.
Yeah.
Then plus what?
Plus H2O.
Plus H2O. sometimes you may need to balance the equation. Sometimes they may ask you to write a balanced chemical equation. So you check, for instance, oxygen, you have 4 oxygen atoms here. How many do you? Okay, you have 5. 4 plus 1. I mean for the reactant side.
It's balanced.
Is it balanced? Yeah, it's balanced. It's balanced.
Yeah.
It's even balanced. Okay, if it wasn't balanced, you would have checked. Okay, it's balanced because we have 5 oxygen atoms in the reactant side and 5 in the product side. 1 magnesium here. 2 hydrogen in reactant, 2 hydrogen here. Okay, now next one is acid plus base or alkali. Also gives salt plus water.
Yeah. Okay, so
What does
now-
that tell you? It means most metal oxides are bases. Because metal oxide plus acid gives salt plus water.
Yeah.
Acid plus base also gives salt plus water. So it means this particular metal oxide has to be a base.
Yeah.
Has to be what?
A base.
What's an alkali, by the way?
It's you know what? You know alkaline, alkaline.
Mm-hmm.
What's the difference between them?
No, alkaline is just the adjective.
It's the same thing.
Yep. Like something is when using an adjective to define how it is. Acidic, alkaline.
Oh.
So what's an alkali?
It's wait, let me. I don't know how to explain it. Isn't it something to do with how
Read what I wrote in yellow.
alkaline base that is soluble in water.
Alkalis are bases that are soluble in water, okay?
Yeah.
There are some bases that are soluble in water that can be dissolved in water, so we call them alkalis. All right. Did you get that?
Yeah. Acids, alkalis are base that are soluble in water.
Not all bases are soluble in water. Those ones that are soluble in water are called alkalis. In fact, they are formed by group 1 and group 2. If you remember, when I told you something about periodic table, group 1 metals are called alkali metals.
Yeah.
Group 2 are called alkali earth metals.
Okay.
So group 1 metals and group 2 metals form bases that are soluble in water. So they form alkalis. Not all bases are soluble in water.
Okay.
The ones that are soluble in water are called alkalis. They are usually formed by group 1 and group 2 metals.
Yeah.
That's actually why they are called alkali metals for group 1 and alkali earth metals for group 2. And they are very reactive. Group 1 metals examples are lithium, sodium, potassium, francium. That's group 1.
Yeah.
They have a valency of 1 plus. Group 2 metals are where you have magnesium, calcium, and so on.
Okay.
All right. So acid plus bases will give you salt plus water. Bases are stuff like something hydroxide. Let me squeeze in an example here. Are you listening?
Yeah.
Let me squeeze in an example here. Like acid, you can have an acid like HCl plus a base NaOH forms although it's better to write the base first before acid, but it doesn't matter. Let's go.
Wait, what did you read? What, to write NaOH and then plus
Yeah, but it's fine. You just write the formula because it's always good to write the metallic stuff first before the non-metallic. In fact, in the equation, the metallic element comes first. Okay, what does it form? Acid plus base equals salt plus water. Okay, so what's the salt?
Oh, okay. That would be Na. Oh,
You're right. Na what?
yeah.
Na we
Na.
call, just
Wait,
it collects CF from that.
NaCl. Yeah, because both
So NaCl.
their valencies are simplified, aren't they? Because they're both two.
Their valencies are for sodium is 1 plus, chlorine is 1 minus. So
One minus.
it's just
Yeah.
NaCl. Okay.
NaCl. H2O.
Plus what?
H2O.
Plus H2O. Plus H2O. This is what we call neutralization reaction. What do we call it?
Yeah. Neutralization reaction.
The reaction
Is it
between,
because it's basically an acid alkali thing?
yeah, because it neutralizes, one neutralizes the other. The reaction between an acid and a base is called neutralization reaction.
Yeah.
Okay?
Okay.
Because acid plus base or alkali gives salt plus water. Let's look at the other rule. Metal carbonate plus acid.
Okay. Salt and carbon dioxide plus water.
Salt,
So
carbon.
that is going to be something plus CO2 plus H2O.
Exactly. Can you give me an example of a metal carbonate? Just a metal with a carbonate.
Let me check.
Let's see. Sodium carbonate. What would be the formula of sodium carbonate, by the way?
Sodium carbonate.
Valency of sodium is 1 plus. Valency of carbonate is 2 minus, remember?
Yeah.
So it will be what?
It'd be, okay, 1 plus 2 minus. So it would be. Wait, can you write it down first?
Yeah, just say it as I can write it down.
It'd be Na2
Na2,
and then carbonate.
carbonate is just CO3.
Yeah, yeah.
CO3 is carbonate. Please.
But I thought you said I thought you said the valency of sodium is 1 minus, or 1 plus.
Yes, valency of sodium is 1 plus. Carbonate itself is CO3. Can you check the table where we have those compound valencies?
Yeah.
Go to page 7 of 20.
I'm on.
Carbonate itself
Oh.
is CO3. Carbonate all together,
Yes, that's 3, yeah.
CO3.
Yeah. Okay. So then, plus CO2 plus H2O.
Okay, so let me zoom it in to 100%. Na2CO3 plus, remember salt plus, okay. No, I'm still forming the reactant, metal carbonate plus acid.
Oh.
So this is the metal carbonate. This is the metal carbonate, right? What's the name of this?
Sodium carbonate.
Sodium carbonate. Okay, plus.
Could you do chlorine?
You want me to use
Yeah.
hydrochloric acid?
Yeah.
Plus acid, HCl.
Could you do like hydrochloric acid?
Or you want me to do
Then-
some? Let me do nitric acid.
Okay.
Nitric acid HNO3. So what will it give?
That would be
First of all, this NO3 itself is nitrate. 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 You can go to that table to find the valency of nitrate.
Nitrate is
That's page 7.
1 minus.
Nitrate is 1 minus.
Yeah, so it'd basically be NO3,
Oh,
just that.
exactly.
And then plus CO2 plus
So
H2O.
this is metal carbonate, which is sodium carbonate, plus acid. Acid is nitric acid, and Na we combine with the nitrate, sodium nitrate, right? Sodium is 1 plus. Remember, the valency of sodium is 1 plus. The valency of nitrate is 1 minus. So it will basically be NaNO3
NO3 plus CO2
plus
H2O.
CO2 plus H2O. You see how these things can be so easy?
Yeah. But you know the valency of the elements. Do they give it to you, or do you need to know them?
These compound ones, right?
Yeah.
You need to memorize them. They don't. You need to memorize them. That table, this table on page 7 is important.
Yeah.
I can always refer to it. Hydroxide is 1 minus. Carbonate is 2 minus. Ammonium is 1 plus. Not ammonia. Ammonia is a gas, a molecule. But ammonium is an ion with 1 plus.
Yeah.
Nitrate is 1 minus. Sulfate is 2 minus. Dichromate is 2 minus. And so many other ones.
Yeah.
So you need to know them. So this kind of reaction,
Yeah.
sometimes they will tell you it causes effervescence or bubbling. What is that thing that is bubbling out?
Carbon dioxide.
Carbon dioxide is bubbling out. In fact, that's why you or they can say it causes a fizzing effect. Fizzy drinks. You understand?
Yeah.
In fact, fizzy drinks is because carbon dioxide bubbles out. That's what causes the fizzing.
Oh, okay.
Yeah. All right. Very quickly, metal plus water. Some metals plus water, especially when the water is hot, like steam,
Yeah.
gives metal hydroxide plus hydrogen.
Hydrogen.
Of course, metal hydroxide is a base.
So something plus H2O is something plus H2.
It's like sodium plus water gives
Yeah.
sodium hydroxide plus hydrogen. Did you get that?
Yeah.
And sodium is an alkali metal, group 1. You understand?
Yeah.
So it
So you
means
know all the when it says like alkaline, would it always be from group 1 then?
say that again.
Whenever there's an like a base used in the formula, is it always from group 1?
No, it's not always from group 1. But if it is an alkaline, it can only come from group 1 and group 2.
Okay.
What's an alkaline again?
There are bases that are soluble in water.
So only groups 1 and group 2 elements, metals, form bases that are soluble in water. Other metals may form bases but may not be soluble in water, like aluminium. Aluminium can form a base, but that base is not soluble in water.
Okay. What about acids? What group is that?
Acid is just acid, but they are bases that are soluble in water. They are bases that are not soluble in water. Okay, you're talking about what forms acid. We are going there. Go to the next page. Go to the next page.
Yeah. Okay.
Now, acidic oxides are usually formed by non-metals when they react with water to form acids. Okay, first of all, non-metals oxides usually react with water to form acids.
Okay. Yeah, non-metal.
Non-metal oxides like SO3. You know, sulfur is a non-metal. I said
Yeah.
non-metal oxide. Give me an example of a non-metal.
Oxygen.
Oh, well, oxygen is a non-metal, but we cannot say oxygen oxide. So give me any other non-metal so that I can talk about non-metal oxides. Sulfur oxide, you understand?
Yes. Not yes.
Nitrogen oxide and so on. Those kind of
Did you
oxides.
say you wouldn't be able to say carbon oxide, would you? Because that would just be carbon dioxide.
Yes, that's also an oxide. Carbon dioxide is an
Oh,
oxide of a non-metal.
okay.
So usually when non-metals combine with water, they form acids.
Yeah.
So I mean non-metal oxides. When they combine with water, they form
Right.
acids. So read what I
Yeah.
wrote here.
Non-metal oxides usually react with water to form acids.
An example is this, right? That's
Yeah.
acidic oxide. Now let's go to number 2, basic oxide.
Some metal oxides react with water to form bases.
Okay. An example is, look at this.
Sodium plus water is sodium
No, I
hydroxide.
didn't say sodium plus water. I said
Sodium oxide plus water.
sodium oxide plus water gives sodium
Na2O plus H2O NaO2.
NaOH. Sodium hydroxide. This sodium
Oh,
hydroxide is a base. It's what?
a base.
Now read this thing I was trying to tell you.
Oxides of group 1 and 2 metals from alkalis. Bases are soluble in water, so are called alkaline alkali earth metals.
Okay, oxides of groups 1 and 2 metals. That's oxides
Yeah.
formed by groups 1 and 2 metals form alkalis. And alkalis are bases that are soluble in water. So they are
Water.
called alkali and alkali metals respectively. Alkali and alkali earth metals respectively. Group 1 called alkali metals. Group 2 called alkali earth metals because they form bases that are soluble in water.
Yeah.
Okay, go to next page. Neutral oxides. Read it out.
Some compounds formed certain oxides are neither acidic nor basic, so are called neutral compounds of oxygen, e.g. NO and CO.
So some compounds form oxides that are neither acidic those oxides are neither acidic or bases,
Yeah.
so they are neutral. Like example is NO. Nitrogen oxide, carbon monoxide are neutral oxides. Take note of that.
Okay.
So it's not all non-metals that form acidic oxides.
Yeah.
And you know nitrogen is a non-metal,
Yeah.
carbon is a non-metal, but their oxides are neutral oxides.
Okay.
They are neither acidic, so some compounds form certain oxides that are neither acidic nor basic. So they are called neutral compounds, compounds of oxygen. Now this last one is what you need to take note of. Read it out.
Amphoteric oxides.
These
These are
are
same method
some
of
metal. There are some metal oxide, example oxides of aluminium, that exhibit both acidic and basic characteristics.
Okay.
For instance, aluminium oxide. Aluminium
Yeah.
oxide can act as an acid. It can also act as a base.
Yeah.
This means aluminium oxide can react with acid to form salt and water. Aluminium oxide can also react with base to form salt and water.
But you just said it is a base.
I told you, even when I was explaining, why did I say it's a base, by the way? When did I say that?
Didn't you say it's a base?
When, let me explain something to you. When did I say that?
Oh, I thought you said aluminium oxide is a base and then. Oh no.
First of all, aluminium is a metal. Not all metallic oxides are bases.
Uh uh.
Maybe that's what you thought I said.
Yeah.
I didn't say all metallic oxides are bases. Look at the definition. Go back to the previous page when I say basic oxides.
Some metal oxides react with water to form bases.
Some, not all. I didn't say all metal oxides. I did not say that. Just some metal oxides. Actually, most metal oxides react with water to form bases. But there are some metal oxides that are both bases and also acid.
Okay.
Now, next page. This aluminum oxide. It can form a base. It can also form an acid. In other words, it can react with water. It can react with a base. And it can react with an acid.
Yeah.
It can neutralize an acid. It can neutralize a base.
Yeah.
So we call them amphoteric. Like they neither belong here, or rather they belong to both. Neutral doesn't belong to any.
Yeah.
But amphoteric belongs to both.
Okay. Amphoteric belongs to both.
Yeah. For instance, aluminum oxide can neutralize an acid. Did you hear me?
Yeah.
If an aluminum oxide can neutralize an acid, what will you call aluminum oxide?
Amphoteric oxide.
No, listen up. Aluminum oxide can neutralize an acid.
Yeah.
It can neutralize. What usually neutralizes an acid?
Oh, an acid and an alkali.
So please generalize it base. Not all bases are alkaline. So use the word base.
Yeah.
I ask you the question again. Aluminum oxide can neutralize an acid. Can do what?
Neutralize an acid.
So what will you call aluminum oxide?
A base.
It's a base because it can neutralize an acid.
Yeah.
And aluminum oxide can also neutralize a base. So what will you call aluminum oxide?
An acid.
Good. So it is both an acid and a base. So it's amphoteric.
Yeah, that's what I said.
Good.
Amphoteric.
It's amphoteric. All right. Later you will work on this. It's been a long haul. I don't want it to get really difficult. You understand?
Yeah. So are the
So you can read it out. Complete the following word equations and write the balanced formula equation.
complete the following word equation and write a balanced formula. So that would be basically what we just did, yeah. I think we did some of them.
Okay, we did some of them.